Welcome everyone to today's video. Today I want to talk about probability. Now all of you have used or have heard this term, but now I want to talk about the difference between the theoretical and real life problem. So basically probability is the chance of an event to occur. Guys, what is the probability that this will happen? But the concept is a little tricky. Even if the probability of an event to occur is 10%, it might still happen. In most movies the hero says that the probability is very low. Remember Doctor Strange? Who says that he has seen 1 billion outcomes and that in only one is where Thanos defeated. Remember that scene in the Avengers?
Be back, Jeremy.
Hey, what was that?
Went forward in time to view alternate futures, to see all the possible outcomes of the coming conflict.
How many did you see?
14,605,000.
How many did we win?
One.
Now, that was a very low probability. Probability is calculated by the favorable outcomes divided by the total no of outcomes. Now, if you talk about previous scenarios, the favorable outcome was only 1, right? And the total number of outcomes was over 1 billion. Now, that is very low probability, right? 1 divided by 1 billion, that is 10 raised to the power minus 9, as still they won. I wonder how. Now, let's talk about some other examples.
I want to show you a very interesting function in Microsoft Excel. This is the random function. What the random function does is that every time it will generate a random number between 0 and 1. Let me refresh it again. See, again it's a random number between 0 and 1. And it will keep on changing again and again. Now, what I want to do is that I want to take this random function and use it as a head or tail. So every time I refresh this function, I will get a new random number. So there's an equal probability that the number will be greater than 0.5 and less than 0.5. Now this is exactly like a coin toss. So I simply round off the function here. So here you can see that there are 10 random numbers being generated, and here on the right hand side I have rounded off all these numbers. So if the number is less than 0.5, I will get a 0 here, and if the number is greater than 0.5, I will get a 1 here. Now here I have calculated the average of all these 10 numbers. If I keep on refreshing, the average keeps on changing, and it is never exactly 0.5 all the time. See, I'll get a 1 here, I get a 0.4 now, I may get a 0.4 again, now I am getting a 0.6. But the probability of getting a 0 or 1 is exactly 0.5, right? Now why am I getting all these different numbers? So basically what happens is that this is the difference between theoretical and experimental probability. Theoretically, the probability should always be equal to 0.5, no matter how many times we refresh. See, now we're getting 0.2. But experimental probability is when this happens and you're getting a different result every time. But then why are we even studying this? Why is theoretical probability even studied if it is never applicable? So basically what happens is that theoretical probability is equal to experimental probability when the number of tests or the number of experiments is very large. See, here we have only 10 experiments, right? But now on this side, I want to do this coin toss, or I want to do this random guess many number of times. So I will do this example over 10 lakh times. So as you can see on the right hand side, I have over 10 lakh simulations running together. So 10 lakh times I will actually refresh this function. Now let's see what will be the result on the average. As you can see, even after refreshing this so many times, the value is always close to 0.5. It is either 0.5 or 0.4999 or 0.5 but it is not deviating that much from 0.5. Now this is where the experimental and theoretical probability coincide.
We will discuss more about probability on another video. Thank you for joining us.